real numbers, algebraic properties of real numbers, right? And their consequences from basic properties, 11 properties which we listed last time. What are the consequences? Because in day-to-day life we are using real numbers very conveniently in banking, in everywhere, in technology, and whatever you field you choose, there we are using real numbers, right? And how we can use it conveniently? Because there are these properties, algebraic properties, 11 properties, and what are the consequences, right? Now we proved that any real number multiplied with 0 is 0, right? So let's choose any real number. I am not choosing particular, because I may choose a special element for which this is true, but that is not a fair game, right? Because if I am saying that for every real number, then I should just close my eyes and select arbitrary real number, and then that should happen for that number, right? I should not have a bias key, choose this and then this is true, therefore it is true. So I have selected any real number arbitrary, just close my eyes and just pick up a real number. Then I want to prove that if I multiply that x with 0, then it comes out to be 0. That is what I want to ensure. Okay, so I have selected, now I am multiplying with 0, but 0 is always equal to 0 plus 0, because 0 is a real number and 0 is a additive identity. So additive identity plus this real number is always a same real number 0, right? That is what the logically I am using in my mind. Correct. When I am say 0 plus 0 is 0 means what is in my mind, what is at the back of my mind, 0 is the additive identity and this 0 is a real number, and therefore their sum is the same number 0. That is what in my mind logically. Okay, so x plus x dot 0 is x dot 0 plus 0, because I have replaced 0 by 0 plus 0. Fine, then I am using distributive property, right? But I don't know what is x into 0. That is what I want to know. X into 0 is 0. That is I want to prove, but right now I don't know, right? So it is ultimately it is a real number. That is clear, because x is a real number, 0 is a real number, and product is a real number. That is because of the axioms M1, right? So this is a real number, no doubt. And by axiom A 3, 4, whatever, this number has additive inverse, right? And their sum is 0. That is just from axiom. X into 0 is a some real number, whatever it has additive inverse, and if I add with it, it comes out to be 0. So in this expression 1, I am adding minus of x times 0 on both sides. Here I am adding minus x dot 0. Here I am adding minus x dot 0. So what I will get here, but this is x dot 0 and minus x dot 0. So additive inverse, so that comes out to be 0. By associativity, I can associate this with this. I will bring them into same bracket, but this is x dot same x. I am using same x. I have already fixed my x, right? I have fixed my x, and I am talking about this particular x. I am not changing x. Remember, same x. This particular candidate is fixed, and for that candidate, same x. Therefore, x times 0 minus x times 0 is 0. What remains? But this is additive identity, this is some real number, so addition is same real number, and therefore ultimately what I get, x times 0, x dot 0 is 0. Is it clear?
Yes, sir.
Yes,
Very
sir.
good. Now, so this is what you already learned in 5th standard, but you did not bother about how this is 0, right? Now we are sure, we have a proof. Clearly this is true. Okay, so you can have many more properties that you were already using since your school. So for example, let A belongs to R, A is a real number, A is not 0. Then prove that. Okay, so what is multiplicative inverse of A? Right, A is a real number. What is the multiplicative inverse of A?
minus 1 by
Multiplicative inverse.
1 by
Very good. 1
by
by or
1 by
or we can also denote it by a raised to minus 1. This is a multiplicative inverse. So Now we are interested in what is multiplicative inverse of 1 by a. Do you understand? What is a 1 by a is a real number basically, right? So multiplicative inverse of a is a real number. This is a new number. Let us call it as b. What is a multiplicative inverse of b? Right. So what is a multiplicative inverse of b means 1 by a is 1 upon 1 by a. Fine. That means it is multiplicative inverse of a inverse. Right. And that we want to understand. If one a is a non-zero element, then prove that multiplicative inverse of a is 8. That means 1 upon 1 by a is a. That is prove that multiplicative inverse of a inverse is a. Right. So question is clear. Please keep your mic off. Somebody has mic on. Please keep your mic off. Okay. So there is a
So,
non.
the
Yes.
multiplicative inverse of 0 doesn't exist, right?
Yeah. Yes. That is what our axiom says. What our
Is it
axiom?
just convention or is there a proof?
This is a basic setup. We don't. The multiplicative inverse of 0 is not defined in the system of real numbers. Right? Not defined in the basic setups. For example, you look at your hall or your house, then there is a door at some wall, but there is no door at another wall. That is your construction, how you constructed your house, and therefore you cannot go outside your hall through that wall which do not have a door. You can go outside your room or you can go outside your house through the door, right? So that is how you constructed your house. Similarly, how the structure of real numbers is constructed or defined by the ancient mathematicians. They do not define. They said that we have not defined multiplicative inverse to 0 because that does not exist in real numbers. Not defined means that does not exist in real numbers. So don't bother about multiplicative inverse of 0 because it is not defined at all.
Okay, sir.
Because if you define multiplicative inverse to 0, then our system will collapse. Why, that you learn later on. But you just right now understand that ki multiplicative inverse of 0 is not defined, does not exist, not available, and therefore the something which is not available, which we cannot think about, or which does not exist, then we cannot think about. Right? Suppose somebody feel that ki I want to play with some alien, but alien does not exist, so we cannot think about this. So forget it, right? That is what the philosophy is.
Okay.
So okay, fine. Okay, so how to prove this? So hint is, what is hint? Multiplicative is unique. This is what the main hint. Multiplicative inverse of non-zero element is if it is unique. No, not more than one. If you understand, so if you use this hint, then what you do? So let, so first of all choose any real number, because I want to prove that for any real number this happens to be true, non-zero real number, right? And therefore I should not keep any bias. So just close your eyes and choose some non-zero real number, forget about 0, right? So choose any real number, then a into 1 by a, what is it?
1.
1.
Very good. Then 1 by a exists. When I say it is in real numbers, means it exists. So a into 1 by a is 1. Very good. So that means 1 by a into a is 1. Am I right?
Yes, sir.
Okay.
Yes.
So So what this last expression suggests, so this suggests that and so one a is a real number, non-zero. A is a 1 by a is multiplicative inverse. So 1 by a is multiplicative, right? Multiplicative inverse of a. Fine. Now this suggests that what this suggests ki this is some number and this is another number and their product is 1. What this suggests? What this suggests? Okay, let me tell you one more thing. Suppose x into y is 1. What this suggests? What this suggests? X into y is 1. That means y is
Y multiplicative inverse
1
of
by
x.
multiplicative inverse of x. Okay. Suppose this is x. 1 by a is x and a is y. So what this suggests?
A is multiplicative inverse of 1 by
A is a multiplicative inverse of 1 by a. Fine. Right? So a is multiplicative inverse of 1 by a. But suppose I call 1 by a is equal to b. Then what is the multiplicative inverse of b? Multiplicative inverse of b is, what is it? 1 by b.
A. Yes.
A.
Right? I am not saying a now. I am talking about 1 by a. So the multiplicative inverse of b is 1 by b. That is what we want to prove it is a. But right now we cannot dare to say that it is a, right? So multiplicative inverse of b is 1 by b. That means multiplicative inverse of b. But what is b? That is multiplicative inverse
1 by A.
of 1 by a is 1 upon 1 by a. Am I right?
Yes.
Yes.
But multiplicative inverse of 1 by a, whatever is 1 by some element, 1 by a itself is a element, and what is the multiplicative inverse of this real number is 1 upon 1 by a. This is what the main point, right? The multiplicative inverse of this real number, what is that real number? 1 by a, whatever it may, it is just named to that real number. So how it face is doesn't matter. So this is a face of that particular number or name of that multiplicative, that number 1 by a. So multiplicative inverse of this number is 1 upon 1 by a. That is it true? Is it true?
Yes.
Very good.
Yes.
But we are saying, and now we are saying that here the multiplicative inverse of 1 a is also multiplicative inverse of 1 by a, and this is also multiplicative inverse of 1 by a, right? This is a multiplicative inverse of 1 by a, and a is also multiplicative inverse of 1 by a. So what is the conclusion? But
Well,
multiplicative
unique.
Inverse is an
inverse is unique. Therefore, you cannot have two different multiplicative inverses, and therefore a is a multiplicative inverse of 1 by a, and 1 upon 1 by a is also multiplicative inverse of 1 by a. They cannot be distinct because unique. So we have this multiplicative inverse of 1 by a is much same as this multiplicative inverse of 1 by a. That's it. And so how we can say that 1 upon 1 by a is a? Because this is possible only because multiplicative inverse is unique, right? So this is a deep philosophical fact. So you are using this conveniently, but there is a lots of basic uh, meaning to it, right? So due to axioms, multiplicative inverse is unique. Fine. That is So this is equivalent to saying that multiplicative inverse of A inverse is A, right? So that is what we know. Fine. So let us go to the next, some basic properties. So what properties we can further discuss? There are many. So whatever you studied so far about real numbers, you can learn all that using the this basic axioms. For example, for A belongs to R, you choose any real number. Minus of minus A is, what is this? What is minus of
A,
minus
A,
A?
A.
So how to prove this? What it suggests, right? So what you need to prove is minus of minus A is A. What we want to prove is, so how will you prove this? Prove this. How to prove? What is hint? Hint is additive inverse is unique. Is additive inverse is unique. This is a hint. That is a, and with this we already proved. Therefore, whatever we are going to do, everything should be verified. Then we'll use it. So additive inverse is unique. We have already verified or proved. So now we can believe additive inverse is unique, right? And now we can use it. We will not going to use anything which we do not have proved or verified, right? We are not going to accept anything blindly. Remember this. We believe only the things which we have already proved or verified, right? We cannot use anything which somebody told you, your school teacher told you, your friends told you. We are not going to use such kind of things. We will be using everything that we have verified, right? Anyway, so how to prove this?
A plus minus A is equal to 0.
Right, so let A is a real number, right? So just choose any, not any particular. So just close your eyes and just pick a real number and work with that, and then prove that minus of minus, that is A. That is our aim. So then, by which axiom there exists minus A, such that A plus of minus A is 0, right? So which axiom? A5, right? Right, what A5 says, ki every real number has additive inverse, and what is the name of its additive inverse? Minus A, right? And we already proved that this is a unique, ekameva advitiya, right? So ekameva, so there is no any other additive inverse. Fine. So but same thing is, I can write it as minus A plus A is equal to 0, by which axiom? A2, right? Commutativity of addition. X plus y is same as y plus x. So therefore A plus minus A is same as minus A plus A. I am using axioms.
Yeah.
I am not using anything which your school teacher told you. Whatever I am using is the which we have proved in our FYBSC class. Right. So forget about whatever you learned so far in your school or till now. So just try to believe on whatever you learn in FYBSC. Right. So this is clear. Now, when I say x plus y is 0, then what does it mean? Y is additive inverse of x.
Okay.
Right. Now, what this suggests? This is x and this is y and this is 0. What this suggests? X plus y is 0 means what? This
A
is
is additive inverse
Is
of minus
additive
A.
inverse of minus A.
A is an additive inverse
Of minus A.
of minus A. Very good. Fine. But already we know that what is additive inverse of some element. But by our previous knowledge, minus a is some candidate, some real number. And what is the name of its additive inverse?
Minus of the real number.
Right, additive inverse of minus a is, right. If I call that b is equal to minus a, then what is additive inverse of b? Minus b. That means minus of minus a. So, but we know that additive inverse, the name of additive inverse of minus a is minus of minus a. Now we are saying that a is additive inverse of minus a, and minus of minus a is also additive inverse of a by uniqueness. Uniqueness of additive inverse, right? By uniqueness of additive inverse, what we can say, so a is additive inverse of minus a, minus of minus a is also additive inverse of minus a. That means there are two additive inverses of minus a, but we know that additive inverse is unique. So what is the conclusion? A is same as
Minus of minus.
very good. So now the thing is clear why minus of minus a is a. Fine. So there are many more properties, and what are these properties? That for example, okay, so I will share this PDF with you. I have some type material. So can you see my PDF type content?
Yes, sir.
Yes, sir.
Yes,
There
sir.
are there are many other properties. Whatever you use so far in your school about real numbers, everything you can prove now. Everything, whatever you have. So I will share with you some of the proofs we have discussed. Some of the proofs are left for exercise. So you should work. I will share in few days this PDF to you. Fine, because I have to work on it further. Anyway. Okay, so that's fine. So whatever you have, you can uh, prove it. So further, let A and B are any two real numbers. When I am selecting A and B, that means I am choosing arbitrary, not any special A and B. Then A into B is 0 implies A is equal to 0 or B is equal to 0. If A and B are two real numbers, then and their product is 0, then one of them must be 0. Right. So how will you prove this? So let AB belongs to R. Choose any real numbers. Suppose product is 0. Suppose their product is 0. So what is your claim? What is our claim? Either A is 0 or B is 0. Right. If one of them is not 0 and product is 0, then second has to be 0. No way, right? So suppose A is not equal to 0, then what we want to prove,
B equal to 0.
B has to be 0. If A is not 0, then B has to be 0, because our assumption is, hypothesis is product is 0, right? Therefore no way B has to be 0 if A is not 0. If A is 0, then nothing to prove. Our job is done, because we wanted, our claim is just one of them is 0. If A is 0, then nothing to prove. But if A is not 0, then B has to be 0. So similarly, if B is not 0, then A has to be 0. If one of them is 0, nothing to prove. Logically, you need to understand this, the strategy. What strategy we are using while proving something. Suppose A is not 0 equal to 0, then what we want, B has to be 0. That means if one of them is not 0, certainly another must be 0. Fine. Suppose A is not equal to 0, that we are assuming. Therefore, A inverse exists. Right? So if A is non-zero, it has a multiplicative inverse. Right? And A into 1 by A. A inverse means A into 1 by A is 1. Right? Fine. Okay. So now consider. Now our claim is ki B must be 0. B. Start with B, but B is same as B into 1 because multiplicative identity is 1. That is because of axiom M4. Right? But B into 1 I can replace by A into 1 by A because A is a non-zero, it has a multiplicative inverse. Then I can write A into 1 by A is 1. Right? So you should give reason to each and every step. I am avoiding the writing reason, but I am telling you reason here, and you in your notebook you should give all the reasons. Now I will use one more property, B into A. Into which property I have used here? Which property I am using here? Associative. Very good. So now this is same as B into A into B into 1 by A. Which property I am using here? I am replacing BA by AB. Which property I am using here?
Commutative.
Commutativity of multiplication. Now, but this bracket is 0. What I am using here? Why this is 0?
Assumption, suppose.
Assumption, hypothesis. Given hypothesis is A into B is 0. Right, and therefore I am replacing bracket by 0. But now this comes out to be 0. Why 0 into 1 by A is 0? Why 0 into 1 by 0? Previous proposition, right? We already proved it, right? So any number into 0 is 0. So therefore, we are using the things which we have verified. We are not blindly using it. Remember this. Everything, each and every step has reason now, right? So this is 0, and therefore we started with B and we reached to 0. So B is equal to 0. Thus, B is equal to 0. Similarly, if B is not equal to 0, then A has to be 0, provided AB is 0. So if we started with B not 0, then we will come out with A is equal to 0. That's it. So product is 0, then one of them must be 0. That is what we are using conveniently in your schools, from your schools, but here we have the proof. Okay, so let A, B are any two real numbers, A not equal to 0, B not equal to 0, then prove that. So AB inverse is A inverse B inverse. That is, prove that what is AB inverse? 1 by AB is 1 by A into 1 by B. Right. So what this suggests ki this is the inverse of multiplicative inverse of AB. And what is the right hand side? Multiplicative inverse of A into multiplicative inverse of B. So do you understand the meaning of this? Many times you people write this conveniently ki 1 upon, for example, many times you write this 1 upon 6 is 1 by 2 into 1 by 3. But why? What does it mean? This suggests this has a philosophy. What is a philosophy? The multiplicative inverse of product of two elements, right? This is a multiplicative inverse of product is product of multiplicative inverses, right? That is multiplicative. So multiplicative inverse of product, multiplicative inverse of product is product of multiplicative inverses. Right, so this is what the meaning of this expression is, and that's why we are using real numbers conveniently, because this happens to be true. Now you write down the proof, because you can now understand how to prove this. Okay, so let us go to the next point. Order properties of real numbers. So order properties of real numbers. So far what we learn algebraic properties, and from that algebraic properties something goes nicely. Some properties of some consequences of properties of real numbers are there, but there are few more properties are needed, right? So far, so the discussion so far which we have, from that discussion we cannot compare which number is smaller and which number is bigger, which real number is smaller, which real number is bigger. That we don't know so far, right? Because this field axioms or order algebraic properties give the knowledge up to this only. Only few properties are clear from this. So there are few more axioms. So what are the order properties? Order axioms. Order properties are also called as order axioms. Whenever I say axioms, then axioms are the building blocks. Axioms are building blocks. Building blocks means what? See, for example, you construct house, then whatever inside your house, for example, in your house there is a computer, there is a table, there is a chair, there is a television, whatever is, there is a sofa set, whatever. These are the consequences that come after building your house, right? So while if you look at any house, the chair, table or television set or computer, these are not axioms. What are the axioms? Bricks or door or window or roof, whatever is, these are axioms. So without door there is no house. Whenever you say, imagine something object like house, then you immediately the door is there in front of your eyes, window is there, tiles are there, whatever is, bricks are there, cement is there. So these are building blocks. Do you understand what I want to say?
Yes, sir.
Very good.
Yes, sir.
So axioms are building blocks that is there while constructing the structures. Therefore axioms or order properties are there from the beginning of construction of real numbers, and whatever later on are consequences, right? So what are the order axioms or order properties? So there is a subset of real numbers denoted by, this is a special symbol for the subset of real numbers. If symbol is not clear, I will write it again, because these symbols are very special symbols. So there is a subset of real numbers denoted by this special symbol P, special P, with following properties. So what are the properties? If xy are in P, then x plus y is in P, and x into y also is in P. So if you choose any two elements from that subset of real number, then their addition is in P and multiplication is also in P. That is what one property. Second property is for any real number x in R exactly one of the following hold. So exactly one of the following hold, x is in P or minus x is in P or x is equal to 0. So there is a subset of real numbers which have these properties. What are the properties? You choose any two numbers from that set P itself, the addition and multiplication remains inside, and you choose any real number, either that number is a member of P or it's negative, its additive inverse is member of P, or that number is 0. Right. Now can you understand what is a set P now? Do you realize where it is possible in set of real numbers?
Yes, sir.
So do you realize such set exists in set of real numbers? Such subset is there?
Yes, sir.
What is that set P?
Integer.
Either positive or negative
Yes.
real numbers.
So the set P is called as the set of positive real numbers. And therefore, what is the definition of positive real numbers? So this is a definition. This is a subset of real numbers having these two properties. What are the properties of positive real numbers? You take two positive real numbers, sum is a positive. You take positive real numbers, product is positive, right? And so if you choose, so this set is a positive real numbers, and you choose any real numbers, arbitrary select, either your number is positive, negative, or 0. That means 0 is neither positive nor negative, right? So am I right?
Yes, sir.
Yes, sir.
Very good. So the such set is called as set of positive real numbers. Now okay, so well, now if x is in P, we write we write it as x is positive greater than 0. So what is this? If x is in P, then we write it as x greater than 0. When x is in P means it is equivalent to saying that x is greater than 0, and therefore this symbol came later on, P greater than, right? So if x is in P, x is thus and if x is not in P, then we write it as, if x is not in P, then what we have,
X less than 0.
so x is not in P means x minus x is in P or x is 0, right? If this fails, x is in P fails, that means x is not in P, but x is not in P means x is in P fails, that means minus x is in P or x is 0. So we write it as x is less than 0 or x is equal to 0. So if x is not in P, or x is not positive real numbers, that means we write it as x is less than or x is equal to 0. That is, x is less than or equal to 0. Right? Either it is less than or equal to 0. Right? This is what the meaning of right. So thus x is not in P means minus x is in P or x is 0. That means minus x is positive or x is 0. Right, so it is equivalent to saying this. So the set minus P is minus x, x belongs to P. That means additive inverses of elements in P is called as set of negative real numbers. As the set of negative real numbers. Fine. So minus P is a set of negative real numbers. Now, okay, so let next A and B are any two real numbers. If A minus B is in P, because if you choose any two real numbers A and B, then A minus B is also real number, no doubt, because it is A plus of minus B. Then we write A minus B is, so A minus B is a real number and it is in P. What if some number is in P? So how do we write it?
Greater
If x
than
is in,
0.
so if x is in P, we write it as x greater than 0. So therefore, if A minus B is in P, then we write it as A minus B greater than 0. That is equivalent to saying that A is greater than B. And therefore, thus A greater than B, if and only if it is equivalent to saying that A minus B is positive. It is equivalent to saying that A minus B is in set P. Right. So what is the meaning of A is greater than B? Right. So fine. Now suppose if A minus B uh, A minus B, suppose B minus A is in P, that means if A minus B is in P, then what can you say about A minus B? What can you say about, because A minus B is minus of B minus A, and we are saying that B minus A is in P.
Then A minus B should be in minus P.
Right. So it is in minus P, because by this property, right, any number either it is in P, that means if it is in P, then its negative is not in P. Right. Exactly one of the following hold. If element is in P, then it is not in minus P. Or if it is in not in P, then its negative is in P, or it is 0. So if B minus A is in P, then A minus B is in minus P. Right. That means A minus B is negative. That means A is less than B. So what does it mean by A is less than B? A is less than B means the B minus A is in. That is what the meaning of less than or greater than. Right. So if A minus B, okay, let me tell one more thing. So is x is not in P is equivalent to saying that x is negative or 0, right? It is equivalent to saying that. Similarly, a minus b is not in a minus b is not in P is equivalent to saying that a minus b is less equal 0. That means a is less equal b. So what is the meaning of a is less equal b? Right. Now, b minus a is not in P is equivalent to saying that a minus b is in P, right? B minus a is not in P, that means its negative is in P union 0, because if a minus b is not in P, then its negative is either its negative is in P or it is 0. That means a minus b is greater equal 0. That means a is greater equal 0, right? So what is the meaning of not 0, b is greater equal b? So what is the meaning of a greater equal b? A greater equal b means a minus b is in P. A less equal b means what? The a minus b is negative or not in P. That is what the meaning of this. So this second property, which we mention, order property, is called as very special name, trichotomy property. Trichotomy property. So therefore, thus the trichotomy property says that for x in R, exactly one of the following is true. So what trichotomy property says? Either x is positive or x is negative or x is equal to 0. Right. So you choose any real number. Exactly the one of this is true. Either that real number is positive. If it is not positive, then it is negative or it is 0. But not two at a time. Not two at a time means there is no real number which is positive as well as negative at a time. Right. So exactly one. That is if x is positive, then x is not negative and x is not 0. Or if x is positive, then x is not x is negative. If x is negative, then x is not positive and x is not 0. Or if x is 0, then x is not positive and x is not exactly one of the. If it is positive, then it is not negative and not 0. If it is negative, then it is not positive and not 0. If it is 0, then it is neither positive nor negative. So thus 0 is neither positive nor negative. What is the conclusion? What is the moral of the story? 0 is neither positive nor negative. So this is one of the important points you should remember. Fine. So the trichotomy properties, the one version of trichotomy property is this. So what is another version or another avatar of trichotomy properties? So for xy belongs to R, one of the following hold. So x is greater than y, or x is less than y, or x is equal to y. So this is the general version of trichotomy property, right, or general avatar of trichotomy property. So that means you pick up any two real numbers. You pick up any two real numbers, either one of them is bigger and another is smaller, or first one is smaller, second is larger, or they are equal. So this is equivalent to saying that key x minus y is positive, because if you choose any two real numbers, then x minus y is a real number, right? And x minus y is a real number, and therefore either x minus y is positive by previous version, first version, or x minus y is negative, or x minus y is 0. So same thing, the same property, same version, but in some general way, right? Fine. So I can say that this is remark 1, trichotomy property. So what is second? Not version, not trichotomy property. So second remark I would like to tell you. So if we arrange real numbers on a line, we put positive real numbers on right side of 0, and first thing we put positive real numbers on right side of 0 and negative negative on left side of 0, right? This is the first thing. So when we rearrange the real numbers on this line, all positives are placed on this side, all negatives are placed on this side. Second point, we put x on right of y if x minus y is positive. Okay, so among these numbers, we are just not putting these numbers like a bag, just putting a bag on this side. So there is a rule how to put. If you choose any two positive real number, where is the position of x and where is the position of y? When x is on right to y, if x minus y is positive. If x minus y is a positive, then I will put x on right side of y. That is a rule. That is order property due to this axioms or trichotomy property. So I will put x on right of y if x minus y is positive. That is a rule, right? So if you keep this rule, then the line is clearly well defined. So negative, positive doesn't matter. Suppose I have a here and b here. So why b is on right side of y? Because b minus a is positive. If b minus a is positive, then that means b is greater than a, right? And therefore I will put b on right side of a. That is what the rule. This is a rule to identify elements or real numbers on real line or line, right? So if x is on right side of y, then we say that x is greater or larger than y. If x is on right side of y, then we say that x is larger, right? And therefore now we are very comfortable with real numbers, because now we can understand which number is larger and which number is smaller, right? And therefore if you move from left to right, the amount or the value of that number goes on increasing, right? So now it is clear, if you move from left to right, the value of number goes on increasing, right? So fine. So in this way we can identify the line. This line is called as real line. line is called as real line because it is filled by real numbers. But only just putting real numbers is not sufficient because we don't know which is bigger, which is smaller, and which number is to be placed at which position. That is also not clear. But now with respect to order properties, we are very sure which number is where and which number is on the right and which number should be on the left on real line, and therefore the complete structure of real line is clear, right? And so this is what the architecture plan of real line. This is architect plan of real line, right? So the engineer or architect give you a plan how to build the building, right? And this is a clear plan. Now there is no confusion which window is where and which door is where and which uh, loft is where, which wall is where. Everything is well defined now, right? And therefore the structure of real number is very clear, correct? So is it clear now? Do you realize that now the structure of real number is clear?
Yes.
Yes, sir.
Right, very good. And do you find it interesting?
Yes.
Yes,
Yes,
sir.
sir. Yes, sir.
And can you see this notebook on your login? In your login, just in your login, go to notebook section.
Yes,
And
sir.
can you,
Yes, sir.
right, and therefore you can read whatever content we are doing. So if you can see from your login, then it is better. You can go through it and try to understand it. And while reading the book that I suggested, you just follow the notes. And after some time, I will upload the video lectures also because I have to do something with it. So you can watch the lectures, also recorded lectures. Fine.